So, hello and welcome. I do hope you are having a spectacular day, and we appreciate that you could join us. I'm your host, Charles Collegy, the security analyst for Accelerated Strategies Group. Now, today's Security Boulevard webinar is brought to you by Orca Security. And I have with me Patrick Pushor, who is the principal technical evangelist at Orca Security. And he'll be speaking on the 6 cloud security risk hiding inside your cloud estate. So, Patrick, could you please introduce yourself or say hello to our audience?
Sure. Hi, Charles. Hi, everybody tuning in. Thank you so much. I'm looking forward to the next hour together.
All right. And Patrick, you're an evangelist, so I'm sure you just want to jump into how somebody or how organizations can choose, or even if they should choose, between strong compliance and risk mitigation against that speed to market. And that's a question that many companies face. However, the meat of today's webinar must be delayed a few moments as I handle the housekeeping items. So please note this webinar is being recorded. So later you will be receiving an email that will present the link to the on-demand. But at any time, you can go to Security Boulevard and gain access to this and all of the archived on-demand webinars that we have available. So feel free to peruse our webinar library. Now, a few comments on the big marker platform we use. First, on the right-hand side of the screen, you'll see the chat button. So we use this a lot. So this feature allows everyone to communicate with us, to say hello, let us know where you're from, interact with us. We really want to hear what you have to say. We want that immediate feedback. Now, for questions, we do ask that you not use the chat, as sometimes some questions can be missed as the chat items scroll down the panel. So we ask that you place questions within the Q&A window, which can be accessed using the Q&A tab, obviously, which is right next to the chat tab. And we'll try to answer as many of your submitted questions as possible before the end of today's session. Now, if we're not able to get to them, I'm sure that Orca Security will follow up. Now, lastly, you'll see the handouts button. This is where you can download today's presentation. Now, the most important housekeeping item for these webinars is at the end of today's session, we will be awarding 4 $25 Amazon gift cards. So please stay with us until the end to see if you are selected. But now it's time to jump into today's session. All right, Patrick, take it away.
Thank you, Charles. And again, thank you, everybody, really, for tuning in and giving us the next about hour of your time. I have about 30 minutes of slide content I'd like to share with you. Goes into sort of the background. In fact, we'll look at the agenda here in just a moment. And then hopefully if we have time and I don't talk a little long-winded like I normally do, I'd like to show you a little bit of the Orca product as it relates to what we're speaking about for sure. And then we'll take some Q&A at the end. So, my role at Orca is to do things like this, kind of in a one-to-many kind of webinar format and sort of spread the Orca message. I also work with customers in sort of an inbound way, trying to best understand their biggest challenges and how obviously we can help craft Orca to meet those. And so I get a real nice mixture of inbound customer knowledge, and then I'm able to sort of turn that around and hopefully share that with you in a meaningful way. So my goal is to give you more than just the Amazon gift card reasons to stay until the end. So with that, let's get going. So first, we'll cover really quickly sort of the evolution of not only cloud, but just how we've done security sort of in the past up until now. It's not a long list. It won't take us very long. And then we'll talk really about how the cloud control plane and the data or workload plane, how considering both of those at the very same time, and in fact, even sharing observations from one to the other is really your secret weapon when prioritizing risk, right? And we'll talk about how difficult prioritizing risk is. Then we'll go into the specific six risks hiding within every cloud estate. We'll wrap with a demo, like I said, if we have that luxury of time at the end, and likewise for some Q&A. Okay, so as we think about how we sort of practice security back in the data center in our perimeter secured networks, most of us were using workload agents back then, right? Not all of us. Some of us trusted that perimeter a little bit too much, and maybe even just for sensitive workloads, we sort of thought about host-based security. But most of us, achieved that host-based visibility by installing workload agents down in those workloads, right? First on physical hosts, then in virtual machines. And the goal was to understand the risks in those workloads, right? Software that exists, the associated vulnerabilities. They look for malware or Trojans, that kind of thing. But the challenge with agents is that you do have to install them on every resource you wish to monitor from a security perspective, right? And security isn't the only domain where agents exist. We use them for performance sort of benchmarking. We use them for backup and DRP. And so, in a typical workload, you can have many, many, many agents running. And sometimes the challenge can be, especially for a security agent that needs fairly deep visibility, you can get into a competition for CPU cycles with, the workloads you're actually trying to protect, right? And that's kind of one of the real ongoing challenges of that agent approach is, the balance between consuming resources for the purpose of security in our discussion versus, the app you're trying to protecting, obviously trying to consume those same resources. There's another problem too in that coverage, right? You have to get to a resource, install an agent before you have any visibility around it. And I think in the data center, when things moved much, much more slowly and, we had different assumptions, that model worked much better. In the public cloud, it doesn't work very well at all. We also saw the advent of the network scanner, right? Back in sort of the data center days. And this one really hasn't made the jump to the cloud as much. We see them, but not quite as much. These are appliances, first sort of physical, now obviously very virtual, that reside on a per network basis and that sort of scan what's on the network, much like your sort of bad actor might, right, from the outside in. So in some ways, that perspective is nice, but it's the same challenge as agents, right? You need one of these per network. And in the public cloud, not only do you need one per network, you may need more than one per network if you've got private resources, right? Or you may need to change the way traffic's routed such that that scanner can see all your resources. It's one of the reasons they haven't been very popular in the cloud. But again, they do exist, especially with those of us just making that jump. We tend to take our old tools and what we know. I mean, it makes sense, right? Along with us on that journey. But I think very quickly we learned that scanners don't scale, right? It's similar to the problem of agents, but almost even worse, right? We can ephemerally create workloads. We can ephemerally create networks for those workloads. We're not going to deploy a scanner and use it for minutes while that workload potentially is up and then is destroyed, right? They don't make that leap in terms of the assumptions we need for the public cloud, mostly being, super agile, super responsive, not using IP addresses as your whole identity, right? Because as we know in the public cloud, IP addresses come and go and they get reused for different purposes and even for different customers. So anything that makes an assumption that my identity is my IP address really doesn't work very well in the public cloud. But then we had this third category of tool that we called a CSPM. And unlike the others, this is a more modern tool, really, has only existed for the last, let's say, decade, maybe only 7 years, really, at least in popular use. And that CSPM stands for Cloud Security Posture Manager. And that is squarely, the purpose of that is squarely to measure the services I use at any of the big infrastructure as a service providers, right? Kind of Amazon, Azure, or GCP, and measure those services I use, right? I might use databases as a service. I might use some storage buckets for files that my application depends on. Make sure that the security controls to do with those services remain consistent. If I am governed by an external data security standard, make sure they remain as that standard sort of prescribes them to. If I'm less interested in formal regulation, but I want to follow best practices, I can do that too and treat it very much like formal, right? So a CSPM doesn't see into the workload. but it sort of sees everything else, all of the security knobs and dials that I've got configured at my platform of choice. It just makes sure that those don't drift and they stay kind of as intended. That's the role of a CSPM. But it doesn't have a workload, a perspective on the workload. It's complementary to sort of agents and scanners in that way, if you will. So that's what a CSPM is. CWPP stands for Cloud Workload Protection Platform. We have kind of webinar tracks or education tracks that talk exclusively about those kind of terms. They are Gartner terms, but fairly widely adopted in the industry. So CSPM, again, is that cloud, let's call it the cloud control plane eyes, right? Keeping eyes on all of those services and their associated security controls all the time. Cloud Workload Protection Platform is similar, but I'm looking down in my workloads. And today, workloads is a little bit gray, right? That means virtual machines. It means containers. It means containers as a service orchestrated by engines like Kubernetes, right? That all falls under Cloud Workload Protection Platform. And then Orca on the far right. Orca was always envisioned, built from the ground up as both a CSPM and a CWPP. We are about 3 years old now, just shy of that. You'll notice that the whole industry really has done this, right? Not built a platform from the ground up like this, but every CSPM vendor has gone out and built or bought CWPP functionality. The reverse is true as well. If you're, an older vendor of a workload agent kind of platform, you have gone and built or bought a CSPM-like capability. And largely it's because I think the writing has been on the wall for a long time. I think if we're talking Gartner terms, Gartner predicted this as far back as 2017, because it doesn't make a lot of sense to consider one and not the other. And maybe going even a step further, it doesn't make a lot of sense not to share information between both sides, right? What I find in a workload, and the next slide is going to illustrate this very well, but what I find in a workload, the very next questions I'm going to have about that aren't going to be answered by what's in the workload. It's going to be answered by what's around it in terms of security controls, because that's what allows systems or user access in or out. And so I can't really answer the tough security questions with just one of these. I need both. And in fact, at Orca, we think that sharing information between these two pillars or verticals or whatever you want to call them, in fact, not really treating them like pillars or separate parts of the product at all. You'll see alerts in Orca that in one category that span both cloud configuration and observations down deep in the workload. And that's very intentional. We think they're inseparable. And so when you think about a CSPM, what does it do? It reads all of that security config largely by API calls. A cloud workload protection platform does the same similar thing, but it's done by installing agents down inside your workloads. And at Orca, we have an approach to do the very same thing as CSPM does, the very same thing as CWPP does. I would argue best in class, but still very similar without any agents, right? And it's through this process of side scanning where we kind of mount the storage to do with your workloads in this side scanner appliance that lives all within Orca. You have no obligation to install really anything to be an Orca customer, but it sort of composes your workload, scans the disks, and it does this in a from the side offline fashion. So no agent inside competing with your workload. It affords Orca quite a bit of extra capability, and we'll talk about that if we have time. In terms of visibility, right, from a CSPM side, you see only the cloud service risks. From the CWPP side, you see only the risks in your workloads. And we can say virtual machine risks. We could add virtual machine and container risks. That's accurate as well. But the point is, each one gives you their own perspective, right? At Orca, unlike, I think, those vendors that have especially gone out and sort of bought the pieces that maybe they lacked at the start, we were envisioned, and the version 1 alpha of Orca included both, right? Both the capability to side scan those workloads and mine that deep configuration for risks, but also at the cloud level side, the Open S3 bucket is the best example of a CSPM kind of cloud level test, right? And one that we read about really, really regularly. So both of those were sort of aspects of Orca very early for a distinct purpose. CSPMs are really, really good at measuring that wide variety of services that attracted us to the public cloud in the first place. CWPPs are really good at runtime protection, understanding when things change, that deep kind of, geez, do I have keys on a disk, SSH keys, maybe credentials to another cloud account that allow me lateral movement. These are the kinds of sort of deep, I don't want to make it sound like CSPM is trivial. It's great at what it does, but a CWPP is down deep in the workload, looking, across every file in your virtual machine, for example. It's a different level of perspective and detail. At Orca, again, they're together. I'll show you in the very first alert category. You can access at Orca. You can see observations down in the workload and misconfigurations on the cloud side as well. So this is a really good exercise to play. I do it often, really for anything that you find down deep in the workload. And there's some good examples here. Maybe I find malware. Maybe I find one half of an SSH key that gives me access to other things. Maybe I find AWS credentials. That's a common one. It shouldn't be, but it is, right? We embed credentials quickly to test something, and because of the speed of the cloud, that test became visible. Everyone loved it. It gets kind of starts to get used as that sort of pre-production slides into production, and all of a sudden you've got something you never intended, and you've got keys that allow, if discovered, obviously allow for some lateral movement. Or in this growing era of really the sensitivity we place on personal data, maybe we've got personally identifiable data, credit card numbers, social security numbers, non-corporate email addresses. Maybe we've got that kind of data where it shouldn't be. Every time I find that, right, and every time I have an alert for something like that, the very next question in a cloud environment, not in my data center, but in a cloud environment, the very next question I'm going to have is, how exposed is it, right? If I find malware, is the machine reachable, right? And that's a question that a platform that only looks inside your workloads, right, a CWPP, a cloud workload protection platform, can't answer by itself. But that CWPP observation of finding malware combined with that CSPM knowledge of all the security controls around your machine, right? And that might include security groups, how your networks are architected, the presence of gateways that allow traffic in or out, not just a dumb lookup of an IP address and is it, publicly routable or not. We're talking about a real complicated calculation of an access path, right? I want that level of detail to be confident that, okay, I found something really, really dangerous, but right now it's not in a state where it can be exploited. Maybe is the resource that it was found, is it even turned on? That may seem kind of backwards, right? With an agent approach, you have no visibility when a machine is off. With Orca's side scanning approach, you do, because we are composing the data volumes that make up your virtual machine or your container, and we're side scanning it. Your workload doesn't have to be turned on. In fact, don't even need to know credentials to your workload, right? It's done on a storage basis, which thankfully each of the big three cloud providers have done a good job of sort of separating out and allowing Orca to take advantage of. So, there's a lot of meat on this slide, but the intention is really to say, as soon as I find something, misplaced PII in a storage bucket's a really good example, right? We don't call these breaches. Sometimes I think we should, just to draw attention to them, right? They're misconfigurations, but the results are disastrous, right? If I've got PII in a storage bucket that's used by my application and that's well governed and that I understand where it is and I've got the right data classification and everything, right? If something changes around the security controls around those and that storage bucket becomes publicly readable, that's something I really need to know about, right? So when I find that PII, I just want to make sure that, again, the security controls around it, and if they're not in a workload, maybe they're in a storage bucket. And again, that's information that a CSPM is great at conveying, but we're missing an opportunity if we don't tie these two together. So, if you do have a cloud workload protection platform now, or maybe you've brought something back, from the data center days, and you've gone and purchased a CSPM, ask yourself if they're sharing data. Right, we'll go through another example where I think it maybe even is a little bit more direct and understandable. Okay, with that, let's get into our 6 specific risks hiding inside every cloud estate. We're going to talk about alert fatigue. We're going to talk about workload coverage as a general discipline or phenomenon. I think it's often overlooked as what we have to consider in the public cloud grows and grows and grows. We tend to forget about the basics, but workload coverage is definitely one. It's not so basic in the public cloud. We have a lot more challenges. Number 3, vulnerabilities in malware. We all do this. If we're not, shame on us, right? In some way, it remains a challenge in the public cloud. We're leveraging open source software more and more with dependent libraries. This becomes a real challenge to make sure that we are updating software, we're patching regularly, both at an operating system level and an application level. So we'll talk about that. Number 4 is the Gartner category that we've all heard the stat for, right? I think initially it was 95% of breaches will be the result of misconfiguration, not negligence at the part of our cloud provider. I think they even revamped that stat to say 99%, right? And it's true. We very, very, very rarely read about something that's the responsibility of one of the big 3 cloud providers having a security implication. It's happened. I don't want to say it hasn't happened, but how often do we read about the inverse, where we haven't quite caught up to the speed of the cloud, right? And so we're terrible at bringing these assumptions along. And one of them is tool sets that do kind of regular spotty verification of security controls. We need something, as microsegmentation kind of flourishes, for example, we go from maintaining a pair or maybe a dozen firewalls when we think about redundancy in the data center days to literally in an enterprise estate, thousands, tens of thousands of these, in terms of security groups wrapped around our micro-segmentation configuration. And so this becomes a management challenge. We'll talk about that. Number 5, lateral movement risk. We've said that a few times already in our presentation today. We'll talk about that more specific. And then authentication risk. And authentication risk is a big enough problem. We've talked about some Gartner terms already that Gartner has wrapped kind of this new CIEM term around it. It's all about IAM rights and the entitlements to those rights, how we get those assigned. These days we assigned rights to more than just users. We assigned rights to resources in an attempt to maybe practice better security hygiene. How often have we heard from developers that they have to embed credentials, even if they have to encrypt them in a file because there's no way to sort of pass them from a workload to a service? We figured all that out, but it does, the solution includes a little bit of risk if you don't really know how it works. And so we'll talk about those authentication risks as well. So the first, I think, of these 6, and it's number 1 for a reason, is this phenomenon of alert fatigue, right? It really boils down to 2 main problems, and we do have separate sort of tracks that speak about this phenomenon because I think it's something we all experience. I think especially if you're an enterprise that has made this decision to sort of go cloud first, and the implication there is that you've got many business units, many project teams, your investment in cloud is significant, and so you've got the CSPM, the Cloud Workload Protection Platform, you've got other security kind of tools and disciplines as well, right? And each of these has an alert stack. You're probably piping these all into your SIEM strategy of choice. You've likely got a security operations center with, a dashboard of health indicators, all in the attempt to really understand what's important as it comes in, what can wait. We know that security administrators are absolutely flooded, right? In any sort of sizable environment, you're going to be generating tens of thousands of alerts. So there has to be this next level, and probably in reality, several levels of filter that really do filter out those that are important to me now versus those that really aren't, those that can wait, right? As we spoke of earlier, context is really the answer, right? What if these vulnerabilities aren't exposed publicly, right? And they can't be remotely exploitable? What if these vulnerabilities have no fix? Right? What am I supposed to necessarily do with that information, right? It's not, if a vulnerability has no fix and it's tucked privately away in my environment, it's still information I want to know, but that should not supersede an alert that, has taken into consideration that, boy, I have a vulnerability. It's known to be remotely exploitable. It's remotely available, given its position in the network and the security controls in front of it. That's an alert I need to receive way quicker than the one we previously spoke of. And right now, these would all be sort of delivered as high severity alerts, right? Platforms today find these vulnerabilities, they look up the external CVSS score, they adopt that as the risk score of the vulnerability. And the challenge is that may not be the risk in your environment due to, again, the cloud security controls around it. So you're never going to get to the bottom of that vulnerability list, right? So something that can work outside of that traditional, not detection. We want the best detection available, but then we want a layer of filter that considers context to help us really understand what to get to first to reduce, the risk of an event and to increase our security posture. These stats really bother me, right? Because I'm reminded of an event. I think we all are, if we've done this for long enough. A breach that happened back in 2013. We learned more about it, I think, in 2014. It was the Target breach at the time. Not that it was especially cloudy, but that it had to do with the phenomenon you see in the right-hand stat here, where just about a third of us report that, we don't consider every single alert in the stack because we deal with false positives so often. We just don't have trust in those alerts, right? And that Target breach was done via malware that was detected, right? It was detected by their security toolset. Their security operations staff saw it, but it wasn't trusted. It was among many other alerts that they felt weren't true. And so, that's pretty natural human phenomenon to sort of group those together. And I think that's one of the key dangers of alert fatigue, right? Just about half of us said that the alerts that they do receive lacked enough intelligence to really, be able to sort of investigate and for sure to remediate. And when you think about it, this is this is probably half of the reason that we have SOAR platforms to begin with, right? Security orchestration and response platforms. A large part of what they do is that they, you connect all of your security SaaS tools or really any tool. You consume those alerts in your SOAR platform, and then you have connectors to add context to them, right? If it's an alert to do with an AWS resource, for example, you probably have a connector that you can easily kind of gather information from the AWS API or a console. That's all to do to the fact that these alerts, one, don't have enough context considered in how they're even raised, but two, then don't have enough actionable information kind of in them, or the platform where they're detected doesn't have enough capability to sort of dig deep. And I'm reminded of an example where an Orca customer had detected malware fairly early. This malware was relatively not understood at the time, but Orca does have the ability to detect malware and sort of chase malware that changes itself, right? We call that sort of polymorphic malware, if it re-encrypts itself every time it's run, for example. Because we don't have to worry about competition with the CPU of that workload, we can throw a lot of CPU cycles at the side scanning process, which detects this. And it's important, and it's quite shocking to me, to be honest, that just about half of us say that when we get an alert, it doesn't have enough information that we need. In this case, when that malware was detected, that customer used another part of the Orca platform where, part of that CWPP or agent-like functionality, remember no agents with Orca, is a CPU kind of meter. And that customer noticed that ever since that alert was raised for malware, their CPU was used considerably and consistently more, right? And so it's not just about having enough information in the alert. That's obviously key. But then does the platform that detects them have enough ancillary capability to help you sort of figure out the puzzle, right? Another real key platform capability is, can I harvest those local security logs from a workload into my cloud platform so that I can do some correlation, right? Can I bring those into the platform without me having to find the resource, find a way to log in, hunt for the log, just surface it to me. If you know the workload well already, bring those logs into that, security platform or however you're doing it so that everything's there in one spot. Right. I think that's what we're aiming for as an industry. I think we're still doing a very poor job. And, SOAR platforms are also really, really key for remediation. That's another consideration for another time. I think we're a little bit a ways as an industry from thinking about automatic remediation of these things, while false positives are still so common, right? The last thing you want to have happen is to close that public S3 bucket if that is intended to be public from your application. How many times, if you're in IT, and especially if you're in security, you probably look like I do every time you're in an application and you click on something and it requests the file from the internet. If you look in the URL, it's coming from S3, right? And usually if it's like a manual or something public, it's coming from an open S3 bucket, right? Intentionally open. So if you're going to tie some automatic remediation to these great capabilities of these platforms, we need a way to differentiate this stuff. We need a way to do really sort of custom measuring and alerting and compliance before we're there. I think as an industry, Light touch auto remediation makes sense. Full auto remediation, I think, is still a little ways away, but we're getting there. So let's talk about context and why it's so important, right? We do a lot of sort of context within Orca. I think part of the reason it works so well is that in the GUI, but even in the data model of Orca, you don't simply get a listing of sort of deviances, right? That's a lot of either CSPMs or CWPPs will generate you a report with a line-by-line listing of sort of what's wrong. Certainly one way to do it. Orca does it a slightly different way where, we build this data model and then we really interrogate that data model for all sorts of things. Yes, those deep down workload observations, but the same data model speaks about all of that cloud security controls and what state they're in as well, right? And so Orca finds all the assets. It finds the roles of those assets, right? If it's a workload and you've got Apache installed and an application server, Orca knows what the role of that virtual machine or container is, right? And so we know what the expectation around it is. We know the standard web ports. We look for ports that maybe aren't standard given the role of that machine, right? Then we understand the connectivity, what's connected to what, the presence of network conventions that allow public traffic in versus not, the route table, right? Really down deep, not a trivial, is this a public IP, but truly how things are connected. And then we'll start to discover the vulnerabilities, right? So it's this sort of data model approach that gives Orca truly the advantage. And let's take an example. I think this underscores it really better than anything. And then we'll quickly get into our demo portion. If whatever you're using right now for workload protection, if it finds a vulnerability, the very same vulnerability in two different places of your network, and I think I alluded to this earlier, what happens is it goes out, it finds that vulnerability, it finds the common CVSS score of that vulnerability. In this case, you can see, I think for illustrative purposes, it's 8.8. And that becomes the risk score of this finding. And that's how really every platform today does this. But I would argue, and we would argue at Orca, that those two findings aren't the same, right? Because one could be very, very well, and I think I gave this kind of anecdotal example already verbally, but one could be very, very well hidden within your network, nice and sequestered away from anything that's public. In fact, maybe it's only connectable by one other spot that it too is very, very private, versus the other occurrence of the very same malware that is remotely exploitable, directly from the outside, very simply. Those two should not hold the same risk score, especially in the context of alert fatigue, where we know, we are flooding that security operations staff with alerts. They, in a typical enterprise environment, they have very little ability to even get to the mediums, right? There are so many severe. Every category of tool treats itself, with a little bit of sort of horse blinders on, right? And considers, I'll give you a really good example. We don't do it in this presentation, but in others, we talk about what is a typical high severity finding in a CSPM. And a high severity finding in a CSPM could be really important, like an open S3 bucket when it's not intended. Or it could be just that, you have a default security group in a region that you don't use that, you should probably address and configure differently. But that should not be a high level, a high risk finding in lieu of everything else that's going on in my environment, right? And so this is probably the largest reason that Orca was conceived as, both a CSPM and a CWPP is let's get this risk scoring engine that's really powered by context working equally on both sides so that, we can truly show you what matters versus what doesn't. Okay, so our second risk is workload coverage. And this is mostly to do with the fact that how it's done today is by, agent installation. And we haven't really we talked about the challenge of sort of competing with CPU cycles. We talked about the challenge of, finding the resource before you install the agent, before you get security visibility. But I think as you think about, this very, very popular paradigm or practice of shifting security left, right? All of us are software publishers these days, right? Even if we're not software companies, we are building web content, we're building portals, we're building HR websites. So we're all software publishers. We all want to think about security in that software publishing pipeline. But to do that, we have to find a way to do it super unobtrusively. If we're going to have this adhered to and observed across our whole organization, we have to make it easy. Part of the challenge with agents is if you want developers to start thinking about security earlier, we have to measure what they do earlier. And we also have to ask them, hey, if you're going to create a new workload, please install this security agent first so that I even know it exists, right? It's sort of a relationship that's almost fraught from the start. What if there was something that didn't require installation per resource, that just sat back and knew every time a new workload debuted, and not only knew, but started that silent side scanning process against that workload then, and then did so regularly from that point on, completely without the need to reach it first, install an agent, and maintain that agent over the life cycle of that workload, right? That's effectively what Orca is. And it's why we built it that way. For us, as we begin to think about how do we govern our cloud estate from a top-down perspective, right? If you're in a big enough organization that's taking a cloud-first kind of perspective, they have a central team that does this. But a central GRC or sort of risk discipline across a whole organization it's a daunting feat. And one of the ways that we can really improve the chances of being able to pull that off is, have a way to measure this that's silent, that nobody even knows is there, right? But that continually measures your workloads and your cloud security service configuration. And that's really, really key. Cloud instances we don't make the same assumptions that we used to, right? IP addresses, we talked about that, how long they live, even the function that they perform, right? Workloads, we used to have these big monolithic workloads that consumed a lot of resources. Now we can spin something up for one particular task and then kill it, right? We've all heard the sort of pets versus cattle analogy, right? We used to treat our workload like pets. When something went wrong, we rushed in, we fixed it. These days, we treat our workloads like cattle. If something's wrong, we do away with it. We fix the problem at the source. We provision a new one. That's how we have confidence that our runtime, our production environments are as secure as they can be, and any changes to them going forward will include all of the security discipline that we've learned kind of over their lifetime. We already talked about that last bullet, right? An agentless approach means no need for cooperation across the organization. And it's not that, we want to do this in a silent and tricky way. What we're talking about is having a tool set and approach that can catch everything, right? That doesn't rely on whether a group can install something or not, or whether somebody starts building a workload from pre-approved images or not. That's simply, in an environment that moves as quickly as a public cloud does, that is simply too fragile, right? Having something that silently sits back and knows about everything. And when I say everything, I mean everything. Maybe someone spins up a new AWS account, right, as part of your organization, but doesn't install Orca to it, right? You need to understand that scenario too and protect that scenario as well, right? And Orca absolutely does with some auto deploy, kind of organization observing feature sets. Again, for the express purpose that this has to be easy. If you want this to be followed, your security approach, your tool set, your process, it has to be easy. Okay, vulnerabilities in malware, absolutely critical. We talked about, for us, the biggest thing or the biggest challenge in how this is done today is, when we discover a vulnerability, when we discover malware, we're looking externally to understand how severe it is. And absolutely, there's a lot of value in that score, a lot of research, a lot of consideration in that external score of a software vulnerability, for example, is important. But it can't be absolute. You can't ignore the environment that it came from, right? And so for us, when we think about vulnerabilities in malware, the detection of such and the environment they're in are inseparable, right? With an agent approach, some of them do an okay job of bringing that information back to a central place where, they can do a little bit of correlation, but you're sort of, by design, you're in the silo of a single workload as you do this scanning, as you do this discovery, right? With Orca, it's quite a bit different. Yes, we're doing the side scanning process that finds those same, and I'd argue quite a bit more detail in terms of risks in your environment. But then we're throwing it all in that data model, and from that point on, we can ask really tough questions of that. And we're talking a lot about security, but there's certainly a whole compliance side and argument to this as well. Going a bit long, I'm gonna move quickly through the rest of these. Misconfigurations, I think we've heard a lot about this. I won't spend a lot of time. It is that category that Gartner has really popularized with this stat, and I think there's even an updated version. But it is because we have a lot of cooks in the kitchen, so to speak. We do not have discrete services anymore, right? I don't log into my hypervisor in the data center, my storage filer, and my routing core, right? I don't have 3 separate credentials for those 3 really important discrete systems in my network. I have 1 set of credentials. And once I log in with those very, very powerful credentials, I can do anything across all of those and more, right? Whatever I consume from a public cloud perspective. And so it's easier than ever, and especially if you're an enterprise org with growing use cases and growing number of people administering this environment, it's really, really easy to make small changes that have massive implications. And so, make sure you have something. If you are single cloud and you're just getting there, you have a handful of resources and a handful of accounts, you can use native tools. We found the Orca customer that comes to Orca at about the 50 to 100 workload, and I know that's vaguely defined on purpose, level. That's about where they feel like they're losing control of not necessarily the workloads, but all the security controls around them. They are many, right? And in a very small kind of lab environment, I installed competitive products to get an idea what it looks like. And many of them tell me I have 6,000 resources in my 7 machine lab environment, because they're inventorying every single network, every single route table, every single permission, even if it's built into these cloud platforms, right? They bring them back for me. I would argue there's a limit in the usefulness of all that. And we'll talk about that in a moment. Lateral movement, an adjacent movement risk. We have to make sure we don't make this easier than it is for those with malicious intent, right? In a workload, the last thing we want to find are features, credentials, keys that allow us, or even information, right? How about a command that I issue at the Linux prompt that's got a password in it? Right? If the next person that logs into that workload with stolen credentials is malicious, all they have to do is look at my shell history and find that password. I mean, it's a real honest and probably something that most security administrators do every single day, with the assumption that the next user is not going to be malicious. But if they are, that's a problem too. So having something that detects if there is sloppy credentials, sloppy passwords in some sort of saved history, that's really, really important as well. So make sure we have something that measures this. And then lastly, authentication risk. And then we'll get to some quick demo time. And then I promise we'll have a little bit of time for Q&A as well. Authentication risk is a growing category, right? We think about this in a traditional way from a workload perspective, making sure people can't log in with the authority to make changes, especially. Very seldom, though, did we publish the remote administrative interfaces of these services in our data center to the internet, right? You had to log into the proprietary local network to be able to administer anything serious. Well, that's not a luxury we have at the public cloud. The bad guys have the very same login potential as the good guys. The only difference are credentials. And that's something that, it's that very basic phenomenon is just an assumption that we don't think much about. But what it means is we have a lot more discipline to practice around how those rights get created, how many high power credentials we have floating out there, right? Why does somebody hold more power in their rights assignments than they need? Often it's out of convenience, right? We have a new hire, we have a contractor, we have an exception to a policy that we haven't really pre-thought out or build an exception policy for. So we're good at kind of scrambling and dealing with the exception. We're much poorer at going back and practicing regular hygiene, cleaning this up, making sure we did it right. Did we do a lazy move and copy an administrator role for our contractor that truly only had one service to work in? That's an incredibly sloppy thing, but it's also an incredibly common thing, and it's something we've always done. But the stakes here in the public cloud, where one set of credentials with an administrator policy attached to them, I mean, if let's say you're a DNS user or consumer, right, a public cloud DNS user, somebody malicious logs in, they can change that. All your users think they're still going to the same host because they're typing those names in their browser bars, but they're being redirected to something malicious that looks just like your website because they have the credentials to clone it because you were sloppy in how you handed these things out. This is the scope of kind of the problem, right? Where one set of credentials, we would never get that same amount of power kind of back in the data center days. So it's really, really key. Okay, with all that said, let me share out my screen and just try to, I always find it useful to try and, tie some things up practically. And so I'll just wait a few seconds to have this show up, but welcome to your Orca dashboard. And the first thing you'll notice, and we'll just drive here into kind of how you onboard with Orca. The first thing you'll notice is really, really simple to connect an account, but also really, really simple to connect multiple accounts, right? You create, so in the case of AWS or Azure or GCP, it's all very similar. You create some policy, you tell Orca how much it can do in these platforms. You then assign that policy to a role that Orca can assume, right? And assuming a role is part of that identity discipline practice we have to practice, right? We have to make sure that not just our users, but any third-party product that we are going to connect to our environment, we know the rights that it needs. We are confident that it's read-only, that it can't make changes in our environment, right? That's the discipline we have to practice, and all of that is available here. It's very much an on-rails process. It takes, if you've done it once, it takes about 90 seconds to do. If you haven't, it's probably a 5-minute process. But from that point on, Orca understands everything that you debut in this account, or if you use the multiple account option, in any child account you build off of your, in AWS example, off of your organizational structure, right? So not just now, but if you add accounts in the future, Orca automatically deploys to them. And again, that is one of the Orca core tenets. You have to make this easy, both for administrators, but also, everyone kind of depending on the information coming out of this. So really easy. If you're comparing this to a CSPM kind of installation process, it's similar. I would argue it's still the quickest I've seen. It's all kind of template driven. If you're logged into the Cloud Console at the time you launch this process, it's completely on Rails and guided. But if you're coming at this from a workload protection platform, this is super different, right? This is not installing an agent on each workload. This is a one-time deployment process, set it and forget it, which is ultimately what you want, right? We don't want a workload to slip through our visibility, right? If I don't get that agent on it, I have no idea that it even exists, right? And orphaned workloads or forgotten about workloads are a little bit like forgotten about children, right? They find ways to get in trouble. Once you're connected, right, the first thing you'll notice is the dashboard where you find the top 5 risks in each category. Really, as you begin to leverage Orca more and more, you'll spend a lot of time in this alerts interface. And all we have to do is filter to the very first category. You heard me talk about lateral movement as one of the distinct kind of risks hiding within all of our estates. But what I want to show you is, just on the first example, you will find a real combination of deep workload discovery, right? And here you'll find this is an AWS alert where we found an insecure SSH private key. And if I take a look at what that means, this is an observation deep within a workload whereby we found a key that provides access to other systems, right? We get a small idea of kind of the attack vector to get there. But then if I look at this alert, right, I can see that I've got a key and that a key applies to different resources kind of in my environment. So that is a workload discovery down deep in this case, it looks like it is a S3 bucket, right? Not a workload at all, but down in an S3 bucket. Here's another one I found in a virtual machine. We talked about the password and shell history kind of example, right? Here's one I found in a virtual machine. And you can tell it's sort of a combination of platforms. Here's some Azure, here's some AWS. But here's an example of a distinctly non-workload specific measurement. That's not entirely true, right? IAM privilege escalation can be in the context of a workload, but this is one where, we can clearly see that the IAM privilege associated with, in this case, a workload. Let's just bring up the whole alert here to read through it. the I am a privileged with a workload means that it's highly privileged, right? And what happens with workloads is, and this is, I alluded to this earlier, we can assign workloads like we can assign users privilege. And what that means is when that workload first spins up, if it's a VM, when it first boots up, you have, as an administrator, you have access to credentials that hold this privilege for a short period of time. You can take these credentials, your application can understand them and use them in its execution. And why we do that is so that we don't have to embed credentials in that workload. We know that is a terrible security practice. And so we allow this more modern method of doing it. But this more modern method, obviously the bad actors know about this as well. They know about if they can get to a workload. Look, if they can get to your cloud console, they don't even have to get to the workload. But if they can only get to a workload, they know that if they can get there on boot time or install something that can see at boot time, they too can harvest those credentials, right? And so it's really important to know that if you've got credentials that are greater than what we think you need for it, if you've got really highly privileged capabilities, maybe you don't need them, and maybe that policy should be more right-sized, right? And so you'll see a really great combination of down deep workload observations and cloud control plane, cloud service misconfigurations, and that's absolutely purposeful. The last thing I'll show you before we get to Q&A, because I know we're a little bit short on time, and I definitely don't want to take more of your time than you've so kindly given us, is this in settings. We know that Orca, as comprehensive as we make it, it is not the entirety of what you need from a security perspective, right? It is not a SIM. It is not a CMDB, although it does a great job of inventory. I would show you if we had a little bit more time. It's right here down in sort of inventory, right? And so you will find a host of integrations within Orca to connect to your environment, right? The last thing we want Orca customers to do is have to adapt their environment to Orca. We would obviously much rather adapt Orca to your environment. So, extensions to CMDBs, extensions to auto ticketing systems, especially those that speak the language of developers, right? As we shift left, making sure what we do is kind of agentless and silentless and fits really, really silently and easily into every process is key. But so too is then making sure we can send the observations in a format into a process that's familiar for those developers. And, Jira, ServiceNow, certainly PagerDuty from a workload perspective, Slack in the effort to support kind of chat ops scenarios. We know a lot of customers are sort of driving in that direction. General webhooks as well. SIMs, this library grows and grows because, again, we understand that one size definitely doesn't fit all, and it's about kind of fitting into your workflow. A super crash course in Orca, but that should leave us a little bit of time for questions.
Waiting for my mic to come on. So thank you, Patrick. One note I'd like to mention is that, if 99% of all the problems were misconfigurations, we probably wouldn't need to do all of the controls we do. So it may not be the best statistic in the world, right?
Yeah, I think the stat is really meant to say, it's not going to be a fault of a security and control of a cloud provider, right? It's going to be the fault of something that we're in control of, because we're not in control of that. It's going to be the fault of the behavior of an application or some unforeseen circumstance we didn't think about. And yeah, it's all within our domain. Let's put it that way.
Yeah, it's within our domain. So it's very interesting that the cloud environment is it is kind of different than what you had in a controlled environment of a physical data center, and it's primarily because of this size and speed. It multiplies the issues. More vulnerabilities, more alert fatigue, as you mentioned. I just can't imagine the alerts cloud generates as over its time.
That's right.
And I've written over the years about context, and I'm glad to see Orca is addressing context, because that's what's important. Now we have probably time for one question, and I say one question because it's a rather long one, and try to look at it. But Mike wants to know that, when you say Orca knows every resource, he's kind of curious about what resources and what can be identified of those resources. Is that something that the IT owner has to provide, or something that you're providing? So he kind of wants to get a little more explanation of
Sure.
what that means. And I think that also probably relates to your discussion of side scanning. I think they're
Yes.
probably Orca knows from that side scanning issue. So if you can get into those points in the next few minutes.
Sounds good, and you're right. It's a wide enough one that's probably the only one we'll get to. Yeah. So I think in the context of let's consider these two pillars again: the CSPM, kind of let's measure all the services we use in the cloud, and CWPP, let's measure the workloads. It's really down kind of in the CWPP side where the bulk of the innovations happened, right? Because if we needed an agent in it, it meant we could only really measure VMs. Can't really have agents in containers. We can, but we don't really know where they're going to run, and that precludes us from maybe understanding exactly how to draw visibility to them, right? And so, for Orca, what it means is any virtual machine, any container you can build in a virtual machine, just as a container. Let's call a roll your own container. Any container that you build that's orchestrated by a proprietary platform like ECS at Amazon, right? It's Kubernetes-like, but it's their own proprietary orchestration engine. And any container you can run in a managed way. So that's Kubernetes on AWS, GCP, or Azure. It's kind of the common denominator, right? It's long speak for any kind of workload that you can run on any of the three big platforms Orca will support, very purposefully. That side scanning process, as you saw in one of the alerts, unintentionally, but I'm glad it came up, also covers storage buckets. And not just S3 buckets, but their equivalents across Azure and GCP as well. So side scanning covers those. The rest of the product covers all of the services, right? So the side scanning applies to the deep discovery of risks in the data of workloads, but Orca at the same time is doing exactly what other CSPMs do, asking questions of the cloud providers like, show me all of your S3 buckets, show me the security controls around them, show me all of your databases as a service, show me the security controls around them. Do they adhere to, either from a compliance perspective, whatever standard I choose, or just are they exposed? Is my remote database from the port calculations, from all the rights I assign to it, are these exposed? Those kind of measurements are also done. So it's sort of side scanning and then your more traditional CSPM kind of tests. They all combine into, support for, I think at last check, we support about 90 cloud services.
All right, so that's all the time we have. And for those who did submit questions, Orca Security will probably be getting in touch with you to help you answer those in the future. So now it's time to announce the attendees who were selected for the $25 Amazon gift cards. They are William V., Tony K., Dina W., and Jack M. So you'll receive an email to the email address you registered for this webinar. And if you're like me, you probably have like 7 email addresses, so you got to check them all. And that email will explain how you can receive your gift. And please also check your spam folder if you do not receive it soon. I want to again thank Patrick Pushor, Orca Security, and you, our audience, for taking an hour out of your day to spend it with us. Goodbye, and may the fickle finger of fate be kind to you.